Hi again. So solving algebraic equations using algebra tiles. So for this one, we'll go back to the integer tiles and the zero principles. So we have to, well, it would be really great if we have yellow tiles and if we have red tiles so we can represent +1 as with yellow tiles and -1 with red tiles. However, I don't have those, so I will do once again with the little dots like this. So +1 and -1. And the super important part is when we have these two together, that's 0. This is very important. Okay, so how can we use algebra tiles to solve algebraic equations? Let's say, what if we have something like this? Okay, let's see. X plus 2 equals 6. So first we're going to divide this into two parts. The important thing is this is a balanced model. So you can use different models to represent algebraic equations, but think of them as almost like a scale. So x plus 2 on one side and 6 on the other side. Whoa, I'm not on the camera. And it is completely balanced. So if you, what that means is if you do one operation to one side, you have to do the same operation to the other side. Otherwise, the scale will tip. Okay, so once again, if you do one operation to one side, you have to do the same operation to the other side, so the scale remains balanced and they won't tip on one side. Okay, so imagine that this is your scale and you have to keep both sides balanced at all times. So what can I do? So we're going to use this little big square to represent the variable x, and we will use the +2 because it's a +2 as this, just like integer tiles. And on the other side we have 1, 2, 3, 4, and 5, and 6. Okay, so that is right now it's balanced right over here. It's balanced completely. So my goal is to isolate x so I can figure out what x is. So I want to isolate, imagine that there's a little 1 right over there. I want to isolate, my goal is isolate 1x. So what is in the way? Those two tiles, the two positive tiles, that's in the way. So I want to do something so that I can actually take that away. What can I do? Well, that's when zero principle comes into play. So what I'm going to do is I'm going to add 2 negative tiles. I'm going to just erase this for now. So okay, so I'm going to add 2 negative tiles, 1 and 2. Remember, if you do one operation to one side, you always have to do the same operation to the other side. So I'm going to add the same amount right over here. Okay, once again, when you do one operation to one side, you have to do exactly the same operation to the other side, so the scale remains balanced. So what do we have here? As you can see, hey, I made some zeros. That's a 0. That's a 0. So you can take that away. Hey, I made more zeros right over here. 0 and 0. Right? So what I have remaining is, I have an x right over here. And what do we have on the other side? I have 1, 2, 3, 4 remaining. So as you can see, x, whoa, you can't see, sorry. I have x remaining right over here, and I have 1, 2, 3, 4 remaining, so x equals +4. So we solved this equation. How are we going to write it down as an algebraic equation itself? In that case, what we did right over here is x plus 2 equals 6. And what did we do first? We added two negative tiles so we can represent this. See, you're doing the same operation. You take away 2, so you can see minus 2, and that created 0. So what's remaining is 4. You can write it up like this if you're just using the algebraic equations, but if you're using algebra tiles, that's how you can represent this algebraic equation and how to solve it. Okay, I'll be back with more problems.